A metallic loop is moved in the magnetic field to generate alternating current or electricity. We apply Fleming's right-hand rule to find the direction of the induced current in the loop. Notice the change in the direction of the current in the blue portion of the loop as it rotates in the magnetic field. When the plane of the coil is perpendicular to the magnetic field lines, the magnetic field lines through the surface of the coil is maximum. Or we can say that the magnetic flux through the coil is maximum. As the coil rotates slightly in this position, the number of magnetic field lines passing through the surface of the coil remains high. There is not much change in the number of magnetic field lines passing through the surface of the coil during such a small rotation. That is, the rate of change of flux is minimum in this position. Therefore, the induced current is also minimum or zero in this position. As the plane of the coil turns further, the magnetic field lines through the surface of the coil start reducing rapidly. The rate of change of flux is large and increasing. The current induced in the coil therefore increases. When the plane of the coil is parallel to the magnetic field, there are no magnetic field lines passing through the surface of the loop. The flux through the surface of the loop is zero. However, as the coil rotates, magnetic field lines start passing through the surface of the coil. This produces large rate of change of flux. The current induced in the coil at this stage is maximum. As the coil turns further, the rate of change of magnetic field lines passing through the surface decreases and the induced current decreases. When the plane of the coil becomes perpendicular to the magnetic field again, the induced current in the coil again becomes zero. The coil turns further. The magnetic flux associated with the coil decreases and the rate of change of flux increases. The induced current in the coil increases, but this time in the opposite direction. By moving such metallic coils by wind, steam or waterfall, AC electricity is generated and supplied to our homes.